So when editing the previous video where I installed and tested the cards, I actually noticed this in the video, and I'm surprised I didn't notice it actually when I inspected the card. I looked at the card visually, but didn't really pay attention to the ribbon cable. And what you can see here is that this cable has essentially melted down. So this red lead has seen a very high current, maybe even the red and orange lead. The red, the red insulation on that red lead has melted. The wire here is exposed. It is black from heat. So something bad has happened to this card, which probably explains why it was in the junk box. I'm kind of thinking about how I want to approach this. I don't necessarily want to completely replace the ribbon cable. There does seem to be down here what looks to be some okay wire here where it's only melted up to about this point. Again, I have what potentially looks like healthy wire here, although when I open this up, remove insulation, I may find that the wire's burned all the way through. So really kind of trying to think what to do to recover this card. Yeah, I'm not really sure. So I think what I'm going to start with is clipping that red lead somewhat out of there, seeing if I can clean up a bit. See, it's melted into the orange wire as well. Yeah, there's no way this is going to be... I mean, the obvious answer is to replace the entire cable. I'm going to assume this red lead was, some kind of power. Yeah, see, that's... just ugly mess. Ugly mess. Let's dig around a bit, see what we can do here. Isolate the red lead here. Of course, where that plastic is burned, it is rather ugly. I guess I could have looked at a schematic for the card and determined what this wire is. Need to be very careful here. This is a very short lead, and stressing it the way I am right now is probably not the right answer. Yeah, the question becomes looking at how this is crimped together. Can I simply pry that little lid up off of there? I see these cards fairly often. Now that I'm watching eBay, these cards and the ribbon cable's always missing, and this cap has been pried off. And so you're just seeing the contacts down inside. So let's see what we've got here. It wouldn't be too difficult to just replace that red lead in line. I do have a pin removal tool someplace that I could remove this pin. I've just got to find the tool, and I honestly have no idea where it is. Let's just see if we can carefully isolate the red wire. Without causing bigger issues. Of course, the correct fix for this is probably to replace the entire ribbon cable. We've isolated the red wire there. The orange and brown wire look okay. They've just got all of this nasty burnt red insulation stuck to them, which I may or may not be able to carefully cut away. Problem is I don't want to get into the brown wire. Yeah, I could, with a bit of work, clean that up. I do have a bit of exposed, I think, wire here. So the other question now becomes, with that wire removed, I don't necessarily see, when we put this board in, the Apple One power supply wouldn't even power up. And the question becomes, is did whatever caused this damage, something nasty happened here externally, take out potentially ICs on this board? I'm actually kind of curious here now that I've kind of got that down and exposed. To just see if I can determine, oops, what that red lead is. So it's +5. So that red lead was carrying +5 out, so I'm not surprised by that. I don't know if the brown one's supposed to carry out +5 as well. I wouldn't be surprised if it was. Oh, Rosie. She's had her cough syrup for the morning. I don't know that it's helping her too much. Apparently not. Yes, I'm cutting towards my finger. I'm well aware. Hopefully you're not getting too much of my bald spot in frame. I'm just trying to be very careful here to not cut into the brown wire and yet get as much of this burnt red wire off of there as possible. Not that ultimately it matters if I elect to leave this ribbon cable intact and just replace the red lead. Because I wouldn't be surprised if brown and red are intentionally hooked together to increase the current carrying capability out to the floppy drive. I kind of assume there's plus 12 coming through this ribbon cable as well for the motor, but you know, maybe there isn't. Man, that is nasty. I'm going to end up cutting towards my finger here. There's just not a lot of choice. Yeah, I'm really surprised when I inspected the card, I just didn't even bother to look at the ribbon cable. You know, you saw me just plug it in and go, wow, it doesn't power up. It should have never been plugged in with this kind of burn, you know, on the ribbon cable. You know, as Dave Jones would say, it's a trap for young players. I know better. And I still kind of in the excitement of, wow, look at all these cards I got, just didn't inspect things as thoroughly as should have been. And I could have paid a high price for that. You know, damaging the Apple itself or the Apple power supply. So the question becomes, I have looking at the back of the board here. So the orange is the second pin right here. Yep, the orange is this pin, and the red is this one, and the red and brown are tied together there. Looking at it from the back side, so that kind of confirms what I thought, where the red and brown actually are tied together. So we know the red wire was open. The question is the brown wire open as well? If I got a component lead floating around here, I can plug in there just to get an electrical connection. No, but I have an old staple here. That should be the brown lead. Now the brown lead has continuity. And the red, of course, doesn't. Boy, I really wonder what somebody did to this card. Look for shorts in the cable between adjacent leads. Sure, I'm really on camera here. I'm just walking through adjacent leads with the continuity tester. We know those are connected. That's where it brings +5 down through the card. So, I wonder if the card got plugged in backwards, perhaps? So, I'm going to assume, where's ground on here? It's a really large ground plane kind of running around there. Can I get some light through the card? Not really. Just let me verify where ground is. I believe it's... Nope. Yep, that would be ground. Really thought that would be a ground there. I guess those aren't connected together. This must be a power bus on the top of the card here. And it is, okay. Pin 25 here is +5. And this pin on the back side is ground. So that should be a ground there. And a TTL device, pin 7. Expect to find a ground being passed through someplace. And there's a couple of them. I can't tell if some of these are guards. Data rate isn't high enough to probably justify it. So really trying to decide where to go next. We've got a couple of transistors here, Q2 and Q3. Let me get in diode test. We'll just take a poke at these. So that looks normal there. There's 0.6 of a volt. Over here, the forward bias is 0.067, which may say that guy is bad. I don't know the transistor well enough. 0.6 and 0.6 forward. We most likely have a bad transistor right there. Open. Open. Yep. Looks to me like we have a short on Q2 here. I don't know which pin's emitter base collector, but it looks to me like we potentially have a short between these two pins. I need to pull the device out and test it out of socket. So that's a problem, and that may be what took this out. Although, why it would take off the ribbon cable. Somebody had to have done something bad on this end of the ribbon cable. Maybe with a cable with a short in it that may have come back and damaged that device. I think for me the next steps on this will probably be to pull the logic out, the proms out, test to see if it'll come up there. Maybe just go ahead and pull these transistors out immediately and just test them out of circuit, because it's possible I'm looking back through something in circuit. But it's 0.06 of a volt forward bias, which is like, no, there's something obviously not right there. Now I'll get the next bit of the game plan together here and I'll be back. So after digging around a bit, I found a schematic for the Apple II Floppy controller, the DIS2 interface card. I've printed it on a nice 11 by 17 here to make it nice and easy to see. I kind of visually compared it to this card, and as far as I can tell, this schematic matches this just fine and dandy, which kind of led me to, I think these two cards electrically are the same. I mean, they're basically the same layout, I believe same components in all the places, the two proms, the transistors, etc. So where I was thinking this was kind of something unique or different from this, I think all that's ultimately different is the way the signals are brought out. With this style, you would of course have a shielded connector that would plug into here and plug into the drive, so you've got proper shielding all the way through to the external floppy drives. That would help with RFI, etc. So this is the card that's got the kludges on the back side. I actually noticed an additional jumper, or is that a scratch? I guess that's a scratch. Anyhow, this is the one we looked at earlier. It's got the jumpers and the trace cuts and just is a mess. But this gives me a donor card potentially for this card. So what I wanted to do at this point, as rude as this is see if the Apple II will now come up with this card in with that red lead removed at this point from the mess here. Before I do that, I will do a couple of things. I'm going to look across the 5-volt rail here on this card for just measure resistance to make sure there's not a short or very low resistance. So I'm seeing about 4K that direction, and it may be a little different this direction just because of slightly biasing devices. Yeah, and about 6.2K in this direction. So there's no direct shorts on here. The transistor that looked like it was potentially bad isn't shorted. There's these two positions here where the resistance was really low, 67 ohms. Let's look at the equivalent over here. $67 ohms. And 100, let's see, a capacitor charging. No, that's mega ohms. That's 75 meg in that direction and open. And yeah, 65, 70 ohms there. So the device I thought maybe was shorted before, or bad, doesn't appear to be actually. Well, it is different. It's 67 in that direction, and it's 67 in that direction. Where, let me try this again over here, make sure I've got good contact. 67. Oh yeah, 67. Okay. So the suspect transistor measures the same on this card. I don't see any shorts on VCC. I'm going to guess where the red cable had melted into the orange cable here. There's actually a bit of exposed wire in the orange cable that had created the short that was potentially keeping the system from powering up with this card on it. So, and this is rather rude to do to this poor Apple II power supply, but I'm going to go ahead and put this card in just long enough to click the power on and see what we get. So I'm getting the Apple II logo. It's trying to boot. There's no floppy. It'll just sit here like this forever. But so that to me quickly confirms that there was a short in the cabling here before I moved that red wire. It doesn't mean this card's okay, but it means it's okay enough. The Apple II's seeing it as a floppy controller and trying to boot a floppy. So I think at this point I am just going to put you back together. Looks like this goes on this orientation. I'm just going to squeeze that back down over the top just to protect it a bit. And I'm going to set this card aside. I haven't decided exactly what I want to do here to repair this. Ultimately, I'd actually like to replace that piece of ribbon cable, which is what I'll probably end up doing, but I'm going to have to find the pin removal tool. I think I've got some female pins as well where I could repopulate this connector and go from there, but that's kind of outside of the scope of what I'm going to do here today. So here's kind of the quick update on where we are with that. And I'll get this edited and uploaded and start the next video.